Now let us continue our talk of black box testing. So ad hoc exploratory testing, or we call it as error guessing. This is based on intuition. Individual intuition means guess what kinds of inputs might cause the program to fail. So we create some test cases which are based on our or your guesses. Intuition will often lead you towards these boundary cases, but not always. So some special case are in boundary values but are mishandled by many programs. For example, try exiting the program while it's still starting up in the phase of starting. Try loading a corrupted file. Try strange but legal URLs. Then comes the comparison testing. This is also called as back-to-back testing. So if you have multiple implementation of the same functionality, what you can do, you can run test inputs through both implementations and compare the result for the equality. This input may be randomly generated or designed manually. So why would you have access to multiple implementations? Because we have safety critical systems sometimes. They might want to use multiple independent implementations of critical modules to ensure the accuracy of the results what they are getting, and you might use competitors product. It is possible, or an earlier version of your own system as the second implementation. So you might write a software simulation of a new chip that serves as a specification to the hardware designers. So after building the chip, you could compare the results computed by the chip hardware with the results computed by the software simulator. Now we have race conditions. So testing for these race conditions and other timing dependency, how to do it. Race conditions means two people, they have one piece of cake, they both want it at the same time. So many systems perform multiple concurrent activities. Operating system manage concurrent activities, interrupts, etc. Server service may many clients simultaneously or concurrently. An application let user perform multiple concurrent actions. So there are the possibility where race conditions may occur. To test a variety of different concurrency scenarios, focusing exactly on activities that are likely to share the resources. And therefore, if two people want the same piece of cake at the same time, there will be a conflict. So race conditions are bugs that occur only when concurrent activities interleave in particular ways, thus making them difficult to reproduce. Means both are stopped, or both are waiting, or both are fighting for a single resource. To test on hardware of various speeds to ensure that your system works well on both slower and faster machine. This is the timing dependency actually we were talking about. Coming to performance testing. Now, performance is a very important term, and performance has various aspects. So we need to measure the system performance by running times of various tasks, memory usage including memory leaks, network usage means does it consume too much bandwidth, does it open too many connections, and disk usages like is the disk footprint reasonable, does it clean up temporary file properly, or process and these thread priorities like does it play well with other application or does it hog the whole machine. All these comes under the performance testing. Then limit testing, and all those testing which we will be talking about, they are what? They are actually the name suggestions. They by their name they say what they are doing. As we have seen in performance testing and limit testing. Limit testing is testing the system at the limits of normal use. So test every limit on the program's behavior defined in the requirement, like maximum number of concurrent users or connection, maximum number of open files, request size, file size, all maximum you test. Whatever is the limit, you cross that limit. So what happens when you go slightly beyond the specified limits? Does the system performance degrade dramatically, or the system, it terminates gracefully? Then comes the stress testing. The testing the system under extreme condition, make the system stressful. give him a or give that system all blood pressure, all sorts of heart problem, everything you give. So beyond the limit of normal use, you try. So create test cases that demand resources in abnormal quantity, frequency, or volume, like low memory conditions, disk faults, network faults, unusually high number of requests, unusually large requests or files, unusually high data rates. So even if the system doesn't need to work in such extreme condition, stress testing is an excellent way to find bugs and find problems. Then comes random testing. Randomly generate test inputs. This could be based on some statistical method. Just create some test input. You are not aware what you are creating. Use any method like test statistical method. So how do you tell if the system succeeded or test case succeeded? Where do the expected result come from? Some type of oracle is needed. This is why this is a random testing. You just randomly check it, and sometimes you check randomly and you find that, oh, this is the error. With the random test, you find the errors. So expected result could be calculated manually, like possible but lot of work. Automated oracles or thinking can often be created to measure characteristics of the system, like performance, did the system crash, or maximum average user response time under simulated user load. Then comes the security testing. Any system that manages sensitive information or performance or performs sensitive functions may become the target of for intrusion people who wants to misuse it. So how feasible is it to break into the system? Learn the techniques which are used by the hackers. Try to think like a hacker. So try whatever attacks you can think of. Hire a security expert to break into the system. If somebody broke in, what damage could they do? And if an authorized user becomes disgruntled, what damage could they do? Then comes the usability testing. What is usability testing? Is the user interface intuitive, easy to use, organized, logical? Does it frustrate user or user happy with that? Or are these common tasks similar to do? Does it conform to platform specific conventions? Get real users to sit down and use the software to perform some tasks. So watch them performing the task, noting things that seems to be to give them trouble, and get their feedback on the user interface and any suggested improvements, and report bugs for any problems they have encountered. Then comes the recovery testing. Now try turning the power off or otherwise crashing the program at arbitrary points during its execution. Like, does the program come back up correctly when you restart it? Was the program's persistent data corrupted, means files, database, etc.? Was the extent of user data loss within acceptable limits? Or can the program recover if it is configuration files have been corrupted or deleted? What about hardware failures? Does the system need to keep working when it hardware fails? So if so, verify that it also does so. Then comes configuration testing. Test on all required hardware configurations: CPU, memory disk, graphic card, network, etc. So test on all required operating system. Use virtualization technologies like VMware and virtual PC. Test as many hardware OS combination as you can. Test installation programs and procedures on all relevant configurations. Then compatibility. Tests to make sure the program is compatible with other program it is supposed to work with. Like, can some word or a later version open the previous version? Save as all, does it save as Word or PDF possible? This, for example, this program is compatible with IE and not Firefox or Chrome. Test all compatibility requirements actually. Then comes the documentation testing. Test all instructions given in the documentation to ensure their completeness and accuracy. For example, how to. These instructions are sometimes not updated to reflect changes in the user interface. So test user documentation on real users to ensure it is clear and complete. So this was an introduction to black box testing. Thank you so much and take care of yourself.